Welcome once again to my YouTube channel. Today we are going to look into a topic in physics, equation of linear motion. Please, I would like you to go back in our previous class where I treated linear motion, the terms related to linear motion. So for you to master this well. Now, equations of motion was propounded by Sir Isaac Newton in 1886. Isaac Newton made out three equations of motion. He has it as equation 1, 2, and equation 3. So we are going to start with Sir Isaac Newton's equation, the very first equation. So Newton first equation of motion he has it as V equal to U plus AT. That's the Newton's first equation of motion. Here, V means final velocity. That is velocity after observation. U means initial velocity. That's velocity at the beginning of observation. A means acceleration. YT means the time taken. So this was derived and can be proved from definition of acceleration. You remember what acceleration is? Yes. So acceleration is change in velocity over time. So from this, we make V the subject of the formula. So if you do that, multiply both sides by t. You have here to the AT. Here, multiply by t, you have this. So we have V minus U. So at this point, if minus U should cross over, that is, or you said add U to both sides, in order to eliminate minus U, you have U plus AT equal to V. Therefore, you now have what? V equal to U plus AT as what? The first equation of Newton. So Newton's first equation of motion. Now let's get to the second equation of motion. The second equation of motion. So the second equation of motion by Sir Isaac Newton, we have it as S equal to ut plus half at squared. So this gives what? The second equation of motion. Now at this very point, S represents distance or displacement. We have here initial velocity, t is the time, while a is what? Acceleration. Now this can be proved. Now to prove this, you remember the formula I gave under average velocity in our previous class. I gave you two formulas for average velocity. That average velocity is initial velocity plus final velocity over 2. I gave this. Also, I gave a formula of average velocity that is the total distance over time. Then we have this. Now, if you combine the two equations, we are going to have total distance equal to, that's this very one, equal to U plus V over 2. Now, make X the subject by multiplying both sides by T. You have S equal to U plus V over 2 times T. So with this, you can now get or prove this very what? S equal to ut plus half at squared. Then from equation 1, we have V equal to U plus AT. Now substitute this very V in this equation. If V is equal to U plus AT, now substitute it here. You are going to have S equal to U plus V, where V is U plus AT. Then all divided by 2. Then times this by T from this very equation. So if you open or simplify, you have U plus U will give you what? 2u, then plus 80 times t all over 2. Now, if you open this bracket, you have s, 2u times t, we give 2ut plus 80 times t, we give 80 squared all over 2. Now, at this point, if you divide the parameters by 2, that is s equal to 2ut divided by 2 plus 80 squared divided by 2. So you are going to have the distance. 2 will cancel 2. We have ut. Then 2 divide 80 squared. It gives you half of it. So we have the what? The formula proved. Then we come to Newton's third equation of motion. So the Newton's third equation of motion has it that v squared is equal to u squared plus 2as. So this gives Newton's third equation of motion. This can as well be proved. Now, to prove this, you remember we've obtained the distance, which is s equal to u plus v over 2 times t. We obtain this by relating the two formulas of average velocity. Now, from equation 1, I would like you to make t the subject of the formula. This is equation 1. So from equation 1, where we have v equal to u plus 80, if you make t the subject, u will cross over, we have v minus u equal to 80. Now, if you divide both sides by a, because we want to make what? T the subject. So a will cancel a. Then it will now remains t, which is v minus u all over a. Now, I would like you to substitute this t in this very formula. Then if you do that, we are going to get a formula, which is Newton's third equation of motion. So at this point, we have s equal to u plus v over 2 times t, where t equal to v minus u over a. Now, if we substitute this very t, we have s equal to u plus v over 2 times t, and our t now is v minus u over a. Now, let's open the bracket. S u plus v we times v minus u, numerator, then 2 we times a. So s now becomes u times v, we give uv. U times minus u, we give minus uv. V times v, we give plus v squared. V times minus u, we give what? Minus uv. Let's take this again. U times v, we give uv, right? Then u times minus u, we give what? U times minus u, we give minus u squared. Okay? Observe it. U times v gives what? uv. U times minus u give minus u squared. Then v times v give what? V squared. V times minus u give minus uv. All divided by 2a. Now we have uv here. Why we have minus uv here? Then they will cancel out. So we have s as what? Minus u squared plus v squared all over 2a. Then we are going to cross multiply. 2 times s, we give 2as. Then we have minus u squared plus v squared. If u squared should cross over this side, we have it to be positive. Then we have v squared. So at this point, we have v squared equal to u squared plus 2as. And that proves the formula. So we have these three equations of motion. Now we are going to solve exercise using these three formulas. But before you do that, there are things I would like you to note well. Of course, from the formula we have 5 parameters in general. We have u, which is initial velocity, we have v, which is final velocity. Remember, velocity is measured in what? In meter per second. Okay? Then we have A as acceleration. Then acceleration is measured in meter per second squared. Then we have T as the time. Time is measured in seconds. Then again, we have S as a what? As a distance or displacement. Then it is measured in meter. Now, like the three formulas in summary, we have it as V equal to U plus AT. Then S equal to UT plus half AT squared. And V squared equal to U squared plus 2AS. So these are the three equations of motion. If you like, you can still include what? S equal to U plus V all over 2 times T. Then at this very point, there are things you need to remember before you are to solve any exercise. You have to note them, 3 of them. Now write. Number 1, are you there? Okay, right. Number 1, when a body moves or accelerates from rest, its initial velocity u equal to 0. I repeat. When a body moves or accelerates from rest, its initial velocity u equal to 0. Number 2, when a body comes to rest or stops, its final velocity v equal to 0. I repeat. When a body comes to rest or stops, its final velocity v equal to 0. And number 3, when a body's velocity is constant or not changing, its acceleration a equal to 0. I repeat. When a body's velocity is constant or not changing, its acceleration a equal to 0.